Well, thank you, Steve, for bringing notes, because then I can bring notes. No, but on behalf of the National Cancer Institute, as well as my boss, the acting NCI director, Doug Lowy, I'd like to extend a warm welcome to everyone here. Doug sends his regrets for not being able to join us, but he and his colleague, Dr. John Schiller, were honored yesterday by the Lasker Foundation for their seminal work in technology advances that enabled the development of an FDA-approved HPV vaccine that prevents cervical cancer and other cancers caused by human papillomavirus. I just wanted to take a few minutes to tell wait for pause, sorry. I just wanted to take a few minutes to tell you a story. It was February 18th, 2009, 7 p.m. at NCI. I was sitting at my desk trying to plan how we would expand a completed pilot in my center called the Cancer Genome Atlas, or TCGA for short. That's when I heard and saw a shadow at my door, a knock, and who was standing there but my former boss, Dr. Anna Barker. Now keep in mind, we had just spent the last 3 years proving that we could perform comprehensive genomic analysis on hundreds of tumors and cancer for 3 tumor types, GBM, lung, and ovarian. And we were just given $60 million by our NCI board to take that and expand that to 2,500 patients across 10 tumor types for the next 5 years. And I preface this by saying, those of you who have met Dr. Barker, you'll know she's a wonderful person to work for, but when she shows up, leaning on your door, arms crossed, that means she's got a wonderful but crazy idea. So she said, you heard that they signed the American Recovery Investment Act just yesterday, right? You think we could somehow use that to accelerate TCGA? What she meant to say was, we're going to use it to accelerate TCGA. Get it done, Jerry. So armed with an additional $100 million in ARA funds, the next year and a half were an absolute blur for me as we planned, designed, and implemented a pipeline that allowed us to double our initial goal and successfully completed genomic analysis on more than 10,000 patients over 25 tumor types in the same planned 5 years. At that time, former Vice President Biden was just this ethereal being to me that had to sign off on my weekly blue sheets. And that's a term just for the US folks, so that our contracts and grants for TCGA could be awarded. I'll admit that there are many late nights where I said not so nice things about those blue sheets and not so nice things about ARA. I just never thought I'd ever meet Vice President Biden. But of course that would change on March 28th, 2016. This time it was around 10 a.m. I was in my office again, planning with a colleague the expansion of yet another pilot program in my center, the Clinical Proteomics Tumor Analysis Consortium, or CPTAC for short. I heard another knock on my office door. Like in 2009, we had just spent 3 years proving that we could do comprehensive proteogenomic analysis on hundreds of TCGA patient samples this time in breast, ovarian, and colorectal cancers. But we're only given $20 million from our NCI board, a third of what we received in 2009 for genomics, to characterize an additional 1,000 patients across 5 tumor types over the next 5 years. I was a bit worried because we had just seen Australia's ProCan announcement saying that they were virtually going to do the same thing, but in a cohort of 70,000 patients. This time I was a bit surprised that it was Doug Lowy at my door, because usually I'm the one that's knocking on his door with crazy ideas. He pulled me aside and he said, so you've heard about this cancer moonshot? The Vice President's team have asked us to reassign you to help them. It was the day that Team OVP unknowingly signed up to hear about proteogenomics for the next 10 months. Every single day. But on a serious note, I'm forever grateful to former Vice President Biden for letting me serve as his Deputy Director for Cancer Research and Technology on his task force, for lending his voice to extend NCI's commitment to data sharing by helping us launch the NCI Genomic Data Commons, coincidentally filled with the 10,000 patients worth of TCGA data that his ARA effort helped get and accelerate, for helping to convince several US agencies to think about proteogenomics, most notably the Department of Defense and the Veterans Health Administration, to build Apollo, our nation's first discovery to delivery proteogenomics cancer care effort housed at VA and DoD hospitals. Henry and I were just at Apollo's third retreat last Friday, where we saw data sets generated since January 20th, 2017, using methods pioneered by Henry and his CPTAC program on tumor samples from more than 200 service members that would not have gotten that otherwise, representing various ethnicities and a majority of them female. For lending his decades of foreign policy experience to reach out and solidify these proteogenomics MOUs with several countries. The International Cancer Proteogenome Consortium self-assembled here after January 20th and are meeting at HUPO for the second time this year. It is a great example of how his vision for the cancer moonshot, where collaborations and partnerships across sectors and international boundaries are essential to accelerate progress. We at the NCI, and certainly myself, cannot do this alone. In closing, Doug wanted me to share two things with you, Mr. Vice President. One, that funds from the 21st Century Cures Act are supporting 7 out of the 10 Blue Ribbon Panel recommendations, with all 10 to be supported next year. And thanks to the Beau Biden Cancer Moonshot dollars, combined with support from the Bill and Melinda Gates Foundation, we're happy to announce that NCI has launched a new international HPV vaccine trial. The trial can lead to eradication of HPV-associated cancer as a worldwide public health problem if it can show truly that a single dose of the vaccine can produce long-term protection against HPV. Mr. Vice President, as my token of thanks to you, I'm happy to announce two things. Just yesterday, my center awarded the very first NCI proteomic data commons that will eventually host the data sets generated by CPTAC, Apollo, and ICPC. And it will be sharing data on the same principles as you saw the genomic data commons do. And last but certainly not least, we put together a special video that launches tonight to help translate proteogenomics for the public. Or as you used to say to me, speak English, Doc.
Precision medicine. The fields that we currently consider next generation molecular medicine, including genomics, proteomics, mRNAomics, microbiomics, and epigenomics all share the same foundation. That foundation rests in omics, which is an informal term used to describe a comprehensive study of the biological components of a cell at the molecular level. Take genomics, for example. Genomics is a comprehensive study of the complete set of genes, DNA, in an organism, which we refer to as the genome. Analyzing the genome of a patient's cancer can reveal information about how to best detect, diagnose, and treat the patient. For example, a patient's cancer may have a DNA mutation that makes it especially sensitive to a drug. Although studying a patient's DNA can provide a lot of information, it doesn't give us the whole picture. The reason is that in addition to DNA, there are many other molecules that contribute to cancer biology, such as proteins. Proteomics is the comprehensive study of the complete set of proteins in an organism, which we refer to as the proteome. Proteins are built from DNA. You might say that DNA is the blueprint for life, and proteins are the tools that make living systems work. They play a major role in the daily functions of both healthy cells and cancer cells. Analyzing a patient's cancer proteome can also provide information about how to best diagnose and treat the patient. This is because proteins carry out almost all of the functions within our cells. If a protein is altered, a cell can begin to multiply uncontrollably, potentially leading to cancer. This is why almost every clinical cancer treatment targets a protein. Understanding how proteins influence cancer biology is critical to developing better diagnosis and treatment strategies, as they can add clarity to how a patient will respond to a particular treatment. In the past, researchers often studied patients' cancer genomes and proteomes separately. But in 2016, research teams combined a comprehensive analysis of patients' cancer genomes and proteomes. This integrated approach of proteomics and genomics is called proteogenomics. These studies show that separately, genomics and proteomics provide a partial picture of cancer biology, but studying them together produced a more complete, unified picture. Researchers are hopeful that proteogenomics may improve our ability to prevent, diagnose, and treat cancer at the molecular level. Proteogenomics research on the frontier of precision medicine. U.S. Department